Okay, so today's video is going to be about USB meters and how you can use them to see many things. You can test devices with it, you can test their charging capabilities as well as their storage with it, and therefore it's pretty useful if you have one of these. I will try to put a link to this in the description so you can get one for yourself and maybe work on it if you're interested in this. But otherwise you can still watch this video where I'll be showing you how this USB meter can be used and show some details. Let us get started with it. Okay, so now that I've connected my USB meter to this power bank, I can show you a few things which are here. The first thing you can see is the voltage. Now voltage is basically the voltage of your power bank or any supply for that matter. This next here is the current. Current is showing 0 because there's no load connected, and this mAh right here, this mAh right here is basically the capacity that is being consumed, that is the energy that you pushed into your device during the charging interval is recorded here. So this is how the USB meter will work. Let me give you a few examples with loads. Okay, so now I've connected my USB meter to one of the power wall adapters which will be used for charging devices, and now let me show how it works when you connect some devices to it. So first thing which I'm doing is I'm going to be connecting my USB fan for the first step. Okay, so I'm going to push the connector here, USB connector, into this, and I'm going to use this USB fan to show you how it measures the parameters. So now that this fan is at its first setting, we can see that the current fluctuates a little bit. The reason why the current fluctuates is mainly because this fan has a PLC based speed controller for this BLDC motor, and that consumes a varying amount of current. But you can see it's a maximum of 1 amp in the lowest setting. Now if you put it in the second setting, which I put it now, you can see that it's consuming a top current delivery of 1.5 amps. Now when I'm at the highest setting, it is consuming approximately 1.8 amperes. Now one more thing which you should note is that all these power supplies have a voltage drop when you put a load on it, and this is known as loading effect of a USB supply. Loading effect is observed not just with these type of power supplies but with the power banks. The open circuit voltage will be around 5 to 5.3 volts, but the moment a powerful load is put down, the voltage will drop. Now if the voltage drops to anything up to 4.85 volts, it is acceptable, but if it drops to less than 4.85 volts, then it is not acceptable. It implies that the power supply is of a pretty low quality, and but the average voltage drop that you will get is between 4.95 to 5.02 volts, which is normal for the highest quality power supplies also when supplying a high current load. Now if you look at it, you see some numbers are being recorded here. What are these? Basically it meant that 30 milliampere hours of capacity has been pushed through this. Now if you want the reading in energy, that is watt hours, you need to multiply it with the voltage at that point in time, and it will give you the watt hour rating. Now if you want to take a fresh reading and you want to reset this, just press this button, it resets to 00. That is how it is. So same thing will work with the power bank too. So I finally connected this off to my power bank itself because it's not very easy to connect it to that one because the length is pretty short, but still it is okay. I can show it to you. Just that the power bank will sometimes switch off, which is why this will switch off, but I can switch it on as always. Yeah. Now let me show you another detail. So let me connect my phone to this. So here is one of my phones right here, and let me connect this one and see how much power it is pulling. Now my phone is charging, and now if you look at it, something might be a bit surprising here. The voltage has risen to 8.97 volts, approximately 9 volts. Man, how has that happened, you might ask me. The thing is, today's devices do not always charge at 5 volts. 5 volts is for slow charging. Now if you want to undertake fast charging, there are chargers which provide higher voltage to your devices, because at a higher voltage you can consume a lesser current and therefore you can increase the efficiency and charge it with the same setup. So if you look at it, since my phone, that is Redmi Note 5, supports fast charging at 9 volts, it is undertaking fast charging. Similarly, even if you look at the nameplate details of this power bank, which it's a bit difficult to see, it shows that there are currently two details, that is, it's 5 volts at 2 amps, 9 volts at 1.67 amps approximately. So this is how most power banks are rated. They can also support fast charging input as well as fast charging output. Now current is less as usual because the phone is almost fully charged, but if I'm using something on the phone, let's say I use something, it will definitely consume more power. I've switched on the flashlight of my phone, which is why it is consuming around 0.5 amperes. I'm going to switch on Wi-Fi and Bluetooth also. Okay, so the current consumption is quite high. If I probably use some energy intensive application like my YouTube, then definitely it's going to increase it even more. This is how, if you look at it, the phone will consume more current when you use power intensive applications during the charge. That's how it is. One good thing about this meter is that it kind of has a memory in it, where even if the power bank gets switched off, it still shows the reading what it previously showed unless you reset it, which I reset it now. Now let me connect another device to this, which is, let's say this got this Bluetooth speaker here, and I will connect this one here to see what happens. Okay, so if you look at it, this power bank also has its own loading effect. Voltage is dropped to 4.97 volts. Again, it is still acceptable. Like I said, average is between 4.95 to 5.02 drop during loading effect. Anything above 4.85 is considerably okay. Beyond that, it's not. Below that, it's not fine. So if you look at it, this Bluetooth speaker is also charging, and since it's almost fully charged, it is kind of like taking lesser amount of current, around 70 milliamps to be precise, and around 1 mAh has been pushed into this. So here's a note about this charging. See, just because like a phone requires, like a device supports fast charging, doesn't mean that the fast charger will simply push a lot of power into it. If it supports slow charging only, then the charger will also charge the device at a lower rate. Whereas if the device supports fast charging, the charger will charge it at a higher rate, which is why you should never manually give a higher voltage supply to the device. You should always use only the charger to charge the device, not any other third party power supply for that. Okay, before I conclude, let me tell you like what is the purpose of this video and purpose of this USB meter. So the purpose of this video was to show how you can use a USB meter to test your equipment, and where can you use this USB meter to test devices is what people might ask me. This USB meter has a lot of applications. As of today, just about every device at home charges from USB, or it can even use type C cables. There are separate meters available for type C, but still we have a lot of USB A and micro USB type ones at home, so we can use this type of a normal meter. Then you can use it for these following applications. First thing you can check is how much current does your device consume. That is the first and most important testing of this that can be achieved by this USB meter. Second, does your device actually consume the current that it specifies, or does it consume something else? Third, what you can do is you can test the capacities of these power banks, charging as well as discharging capacities of the power bank. And if your device has a battery in it, like let's say this power bank or anything else, you can also check how much mAh was pushed into the device. If you want to discharge a power bank and test its discharge, that is also possible, because you can push that much power into the device and see how much your power bank is discharging. So you can test just about any device you want. You can test the voltage, current and the energy in mAh. If you multiply it into this voltage reading at that time, it will give you in watt hours. Just that you must note that since it's mAh divided by 1000 before pushing it into multiplying to voltage, that you can get it in solid watt hours, or you should take it in milliwatt hours. So that's the only thing. Otherwise you can use this meter. It's pretty easy and you can test a lot of things, whether they're telling the truth or not. You can actually test their nameplate details and see whether it matches with the reading on this. I'm concluding this video for now. Thank you so much for watching. Like, comment, share and subscribe. Stay tuned. I will see you in the next video.